This is the last topic, tree diagrams. So we're going to do this question here. Jose travels to school on a bus. On any day, the probability that Jose will miss the bus is a third. If he misses his bus, the probability he's late for school is 7/8. If he does not miss the bus, the probability is 3/8. Let E be the event he misses the bus. Let F be the event he is late for school. Draw a tree diagram of this information. You guys know how to draw a tree diagram, or should we do it together?
Yeah.
So with the tree diagram, I think tree diagrams is my favorite method for solving probability problems. I know even when I was doing university type problems, I would often sketch a bit of a tree diagram instead of just going straight to the problems. Probability is my weakest subject. So I really like this technique. It helps me visualize it. So we start off with the tree diagram. We have two possible decisions, like this. So what we have here in our first two decisions is, let me see which one will go first. So does he miss the bus or not? So this is the event that he misses the bus. So here in this one, at this point, this is event E. Event E has to occur first. This is whether he misses the bus. So we have two probabilities. He misses the bus. What's the opposite of missing the bus? Not missing the bus. So not missing the bus. So here we have the probability of event E, and here we have the probability of not E. So can we work out what the probability of E is? The probability that Jose misses the bus.
Can I drop you for a second?
Yes. Is it crucial? We're in the middle of a lecture.
Yeah, a little.
Yeah. So it says here that the probability he misses the bus is a third. What does that mean the probability he doesn't miss the bus is? 2/3. It's always complementary. It's always complementary. This one's 2/3. So next up we have another possible event. It always branches out a bit like this. So this next one is event F. This is event F. Event F is he is late for school. So let me squeeze that in here. Late for school. I'll call that late. So we have the probability of event F or not F. But here is the probability of F as well, and here is not F. Now these two second sets of branches are conditional on what happened in the first event. Because he's more likely to be late for school if he misses the bus. He can still get there. So we get more information. If he misses the bus, the probability that he's late for school is 7/8. That's this one, 7/8. So what's the probability here going to be? 1/8. Always the complement. Sorry, I want to break that. If he doesn't miss the bus, oh, have we got this in the wrong place? No, misses the bus. He doesn't miss the bus. We come down here. So if he doesn't miss the bus, the probability that he will be late is 3/8. So the probability here, what's the probability of not being late? 5/8. And get 5/8. So this is the tree diagram and how it looks. This is the tree diagram. I'll give you a minute or two to copy it down.
So what is that? What's over 8? 7/8?
7/8, 1/8, 3/8, 5/8.
I don't understand this.
You have to pick it apart. So firstly we have to decide whether he misses the bus or not. This is our first event.
Right.
So he misses the bus, he doesn't miss the bus. So then it says if he misses the bus, that means you've got to have traveled down this branch. So then you get two more
Two
possibilities.
possibilities if you went through that possibility. Okay. Oh, so it's just branching out. But I don't understand the PE and then the P and like the how you wrote it down. That's a probability.
So this is the probability. The probability of event E is 1/3.
Right. But then I'm talking about the other when they branch out like that.
So this is the probability of whether he's late for school or not, based on the fact that he missed the bus. Whereas this is the probability he's late for school or not, based on the fact he didn't miss the bus.
Oh, because the slides that you posted here show that you did like something else. So I just got confused.
Yeah, so I'm just using more notation. It's the probability of event E. This is the probability of F given E. This is not F given E. This F is not E.
But I can do that as well.
It's the
It's the same, right?
It's the same. The numbers should be the same.
Yeah, the numbers are the same.
Okay, let's move on. So here on this one, we need to find a few probabilities. So firstly, we need to find the probability of the intersection of E and F. That means we want E to occur and F to occur. The only place that this happens, if we want E to occur, we have to have this. If we want F to occur, we have to have this. So we have to get to this leaf here. So this is the probability of the intersection of E and F. That means E has to happen, F has to happen. We have to come here. So to get these ones, when you're working with a 2E diagram, the leaf nodes are always the multiplication of the branches you traveled along. So for this one, this is going to be equal to 1/3 times 7/8. And this gives us 7/24. So we want the intersection of E and F. That means E occurs, F occurs. That only happens in one place.
So do we always have to simplify or?
Typically, with these type of tree diagrams, all of the leaf node probabilities will be over 24. Some will simplify and some won't. So I tend to leave them unsimplified because sometimes we have to add them together. So if they're all over 24, much easier to add them. Okay, we need the probability of F. So what does F mean? What does the probability of event F mean? That he is late. Is there more than one way that can happen?
Yeah.
So he can be late if we get to here, but he can also be late if we get to here. So we need this leaf node as well. So the probability of him being late is going to be that one, or this one. How would we calculate this one? So this one is going to be 2/3 times 3/8, which is going to be 7 plus 6/24, which would be 13/24. That's why it's better not to simplify that 6/24.
So you're recording this?
Yeah, you will.
Yes. Let me just double check. Yes. Okay, let's try B. Find the probability that Jose misses the bus and is not late for work. So he misses the bus, but he's not late. So he misses the bus. He is not late. So we want this one. So here, we want the probability that he is not late, given that he has missed the bus. This is the probability that he is not late, given that he has missed the bus. So he is not late, he has missed the bus. So this is 1/3 times 1/8 which is 1 over 24. Actually, it's not. Sorry. This is the probability of E intersection not F. Sorry, that was wrong. That was wrong. We want him to miss the bus, that's E. Not late, that's not F. And then we need the intersection of the two. Jose missed the bus given that he is late for school. Jose misses the bus given that he is late. So for this one, we want that. For this next one, he missed the bus given that he is late.
How do you want us to do this?
Isn't it 2 over 3 times 2 over 8?
What we like to start? Refresh. Wait, so
Sorry, this is a little bit trickier.
I think what you did in the beginning was right.
Yeah.
Not F given E. Because you're two not.
Oh, that is correct.
Not F given E.
So we can turn this easily. Its answering is a little bit trickier. Jose misses the bus. So this one would be that we can turn this into symbols. He misses the bus. So that's E. Given this has occurred.
As you're doing number 2 of B.
Sorry, I'm just thinking through. I don't want to get this wrong. He's missed the bus, E, given he is late for school, F. This one is a little bit trickier. So what we want to do is we need to fall back on the formula for this one. So what is the formula for this one? What is the formula for conditional probability? Find it on the formula sheet. Because this, we want this, but the thing is, what makes this one tricky.
But wouldn't it just be E intersection F? Why would it be
We want this,
E given F?
but we know that these ones have been removed, so the tree diagram has been made smaller. We want this branch to occur, but we know that these parts of the tree diagram have been removed, so the total probability is less. So if you look to your formula sheet, yeah, I want to show it to everybody so they see it. Most people haven't bothered to open it. The formula sheet is available on the Google Classroom. So if I ask you to open the formula sheet and you don't have a paper copy of it, you can go to the Google Classroom and you can open it. Can we put that in? Open the formula booklet. We need to find conditional probability. Where is the formula? Malik.
So page 9. Page 7.
Depends which version of the formula sheet you're opening.
Oh, where is it like topic?
It's in topic
4.
topic 4, 4.6.
Yeah.
This is the formula. This is the formula. A given B is the intersection of A and B over B. So if it's given that B has occurred, that is the total probability. The probability of B. So coming back to our question, this is going to be the probability of E intersection F over the probability of F. This is going to be the probability of E intersection F over the probability of F. Now, what is the probability of F? What does it mean? He's late for school. Have we calculated that?
Yes.
What is the answer? 13 over 24. So this one is 13 over 24. Have we calculated the intersection of E and F?
Yeah.
Which one is that? This is 7 over 24. Because these are both over 24, we don't need that bit. It's 7 over 13. So it's not a third. This is the probability that he misses the bus. We are trying to find that he missed the bus, not a third. Probably he missed the bus is a third, but the probability he missed the bus, given that he's late for school, is because these two parts of the tree diagram are removed. So only these two parts of the tree diagram are possible, and we're wanting to know what is the probability that this one has occurred and not this one. So this reduces the probability and changes it. We need to use the formula for this one. We need the intersection of these two divided by the total probability here. So this is the probability that he is late for school, 13 over 24. It's the sum of these two. It's the sum of these two branches. This is the probability that he misses the bus and is late for school. That's this one. Now this one is the probability he misses the bus given that he's late for school.
So I don't really understand A2
This one, this is the probability. So let me just go over them a little bit more now. So this one here is the probability that he misses the bus and is late for school. That means we have to travel along here. Miss the bus, late for school, you get that leaf note. On this one, we want him to be late for school. So for him to be late for school, he either missed the bus and was late for school, or he caught the bus and is late for school. We need these two possibilities for this one. So this means we have to sum these two. So we need this times this times this, and then you add the two. So this one plus this one. Let me undo a bit of that.
I don't really get V1. Why is it 1 over 3 times 1 over 8 when the numbers are 2 over 3 and 5 over 8?
Find the probability that Jose misses his bus and is not late for school. So he misses the bus and is not late for school.
Yeah.
1 over 3 times 1 over 8.
I was looking at the problem one second.
Okay. We're going to do some Venn diagram ones now.
So we pull up the
A given B. If you're given B, B's in the bottom. So whatever you're given is the total probability that goes in the bottom. So on this one, given that he's late for school, so that's the total probability. he's late for school. That's the probability of F. We calculated that one by finding these two lengths and summing them. We calculated that one earlier.
That's talking about the one that also got
This is the intersection of E and F. That means he misses the bus and is late for school. That's just one leaf.
So both together.
This one is, so this one on the top is this one leaf here.
Yes, like both of them happen together. Yeah, and F.
Yeah. Both of them happen together.
Both of them given just the downside. Because you said if you give it F, then it's just probability of F. You're given P of E.
You can do the formula the other way up for this one. Otherwise, it actually simplifies quite a bit if you do it the other way around. And it becomes this branch, basically. Because you know this is a curve. So if writing this the other way around, of F given E, it's simply that 3/8. Because you know this is a curve. When I'm doing the little red bits where I'm reducing the probabilities, what am I taking off here? When I'm reducing the probabilities and I'm taking ones up over there, it's tricky. But if I just simply take off all of this, and I tell you this has occurred, it's just those two.
This probability of the intersection as 1.3 times 7.
Sorry, let me just write it here on this one. So this one here is the probability of F given not E.
Intersecting F, meaning like both of them happen. So if that means 3 times.
So you need that. Okay, have a go at this question.
I have two questions. For the minor observation, is it multiple choice?
Mix.
And we don't have to.
No, it answers in
Additional. And second, the major is it just event A occurs lesson 1, 2, 3. This year or this year?
No, the major is unit 4 and 5.
So if you.
Yes.
Still using.
Yes. Yeah. Only 2 units.
Okay, 7 lessons, 1 unit.
So the next one will also be 2 units. 7 and that will be 7.
Thank you.
The one after that will be in grade 12 with 1 unit. And the one after that will be 9 units. And the one after that will be 12.
So it's all different measures of separation. From December.
Nice, try not to some data.
Mr. Smith is someone else.
Is that a bug? Huh? Shit.
Wait, I'm gonna put it on your desk so you can. What is that?
Is that actual shit?
Yeah, it's real shit. You know,
That's what I'm about to go.
Really? No, I am.
So slow. We take 4 months by that.
Really? How would you?
Because you only have a number.
Oh, it is comfy. Yeah, but like it's not hard. Flexible to. Who knows, by the way? I'm going to 24/7 right away.
This one.
He's in here?
You know that this is just.
That's why you're not bad.
And then this is the same way around.
Like I wanted obviously compared to always happens each other about and you know we don't want to literally know each other.
Which one is 2
No, I'm so good at I literally don't even social shower.
Okay, let's have a look at our answers. Let's have a look at our answers. This was a bit easier. So for A, we need the probability of event S. What's that one going to be?
S? 7.
No. No.
7 over 28.
Masha? 7 over 28. Okay, could we stop talking? Let's focus a little bit better. Khaled?
Khaled.
Sorry, Khaled. Sorry, we want this one. We want this one. This is event S. There's a total of 28 in the diagram. This is event S. So for this next one, we need the probability of I. What's this one going to be? 8 over 28. C. We need the probability of S given I. So for this one, I has occurred. So this part of the Venn diagram disappears. This part disappears. We now want to find the probability of this out of the total. So this one is going to be 2 out of 8. D.
2 over 7.
We want the probability of I given S. Anyone else? Anyone else? Anyone? Somebody else? 2 over 7. E. We want the probability of I intersection S. Let me go for Lucas. No. 2 over 28. F. We want the probability of S times the probability of I. What's the probability of S?
7 over 28.
7 over 28. And the probability of I?
8 over 28.
8 over 28. Put this into our calculator and simplify. What do we get? Guys,
1 over 14.
1 over 14. Last question. Are in events S and I independent? Why not, Ella? Are the events independent? Look to your formula sheet. Open your formula sheet up now. Open a formula sheet up now. Find the formula for independent events. Do that now. You come out and see the formula sheet.
Because 2 over 28 is the intersection, and the thing is, the intersection is this time, so it's just F. F, you got 1 over 14, and 1 over
What is the intersection?
intersection here says 2, right? Or 2 over 28.
You simplify it.
Ooh, no cute.
Without this calculator. Oh,
Yeah, 1 over 14.
so
There they are.
there we go.
But how do we know if they are the
Okay. So let me see your formula sheet. Which one are you using? So in our formula, we want this formula for independent events. Events are independent if the intersection equals to the product of each event. So for our last one, the probability of the intersection is equal to 2 over 28. Does this simplify?
Yes.
What does it become?
1 over 14.
1 over 14. And what's that equal to? It's equal to this one. What does this imply? They are independent. Okay, have a go at the questions from the book. Would anyone like to borrow the physical book? Oh, yeah. Who's he? Who's he? I don't know. Walk through my house. Close physical contact. You guys have it?
I'm joking. Okay. The mean number of passwords used the internet is 2. So find the value of k.
Right. So, K, add all of these up. Add K. Divided by, let me write it down. So we wanted to calculate that. We need to use the sum of x times the frequency over
And so.
And then 7 equal to.
No. Wait.
You get the formula?
I get it.
Sorry, somebody's lost their food.
Oh yeah, that's fine.
You couldn't tell the It's pretty straightforward on that one. So we have this formula for to test for independence. So if the intersection of A and B equals the product of A times B, then it's independent. So look to the video from last class because I explained it conceptually why it doesn't occur. It's to do with the ratios between the two.
What about the mutually exclusive events?
Mutually exclusive events are events that can't happen at the same time. So one of the most important formulas is the independent events. So the union of the two is the probabilities of each one minus the intersection. I talked about this a few times in the last couple of lessons. Now, in the case of mutually exclusive events, the intersection is 0. So this disappears from the formula because it's always 0.
So you can tell that something's a mutually exclusive event when the probability of the intersection is 0?
Yeah.
Okay, thank you, sir.
And as a Venn diagram, you've got 2 circles that don't intersect. That would be the probability of taking AI and AA standard at the same time. And there are some other ones that they're not mutually exclusive. So some of them, like probabilistic biology, isn't completely exclusive in chemistry. Because some kids have to take one science, and they're only going to take 2. But some take both. They're not mutually exclusive. Yeah.
Sir, I have a quick question.
The approach is to learning.
She's probably returning a box to art. What do you mean? You be waiting for us. I think we should get to
You think it'll actually? Sir, it was her.
So if we say how much more do you need to make this less? But this becomes 0.
Can we get started with some math problems?
Yeah.
Today?
I know. So it turns back to 1.
Go from something.
Sorry.
You said
Okay, so we have one, and from the one, again, yeah, so say it's number three, it's from one. Yes.